Hydrology for watershed management. In the reward program, integration of land resource inventory with hydrological variables is done to develop robust integrated watershed management plans. If you look at the hydrology data, it includes rainfall, evapotranspiration, soil moisture, infiltration, runoff, groundwater levels, recharge, and draft. Let's see how these data is generated in reward programs in the subsequent slides. Now, if you look at how hydrological data is generated, the weather data, infiltration, soil moisture, monitoring groundwater levels, borewell discharge for yield assessment, measurement of runoff and sediment yield, sediment analysis, and water budgeting. Based on this, existing conservation or harvesting structures is done. Based on the rainfall data, rainfall indices depicting the deviation from annual averages and different crop seasons are prepared. With this rainfall indices, it is easy to understand the deficient and excessive rainfall that can be used for estimation of runoff. Next important parameter under weather data is evapotranspiration. It is the amount of water that evaporates from the surface and transpired by plants. This is required for the estimation of water balance and crop water requirement. We consider two types of evapotranspiration, that is, potential ET and actual ET. Potential evapotranspiration means the ET that takes place when unlimited water moisture condition exists. Actual evapotranspiration means ET that takes place under existing soil moisture conditions. If you examine the graphs, in the third graph, which represents monthly AET versus RF, we can see during May, August, September, October, November months, the actual evapotranspiration is less than the precipitation, leading to the inference that runoff can occur. Same thing is depicted in the hydrology atlas. Next step in the evapotranspiration presentation is preparation of ET index map. The index map is prepared considering precipitation, potential evapotranspiration, and water energy balance is computed and depicted in Budowko curve. If dryness index is less than 1, runoff can take place. Here is an example. If you look at the actual evapotranspiration, 2010 and 2014 were water deficit years, and the suggested crops are less water requiring crops like cereals and millets. Actual evapotranspiration is assessed through leaf area index meter, and coefficient values are computed based on the actual evapotranspiration, and this Kc value is required for estimating crop water requirement. Measurement of infiltration rate is done through double ring infiltrometer and is done to estimate runoff. The soil moisture is yet another parameter considered under hydrology data. The soil moisture is assessed to know the volume of water storage in the soil, to calibrate satellite moisture data, monitor drought condition, crop water requirement, and life-saving irrigation. Hydrogo instrument is used to measure surface soil moisture and time domain reflectometer to measure soil profile moisture. Profile soil moisture is measured using time domain reflectometer at different depths such as 15, 30, 45 cm up to soil depth in different soil phases. Then we assess the groundwater level, and these are measured to estimate recharge factor, and this is assessed through manual water levels and automatic groundwater level sensors. The graph represents the rainfall received in micro watershed, and the corresponding map represents groundwater levels during different crop seasons. The graph depicts before and after implementation of watershed program in Tumkur district. If you look at the graph, the average groundwater levels have increased from October 2021 to April 2024. The table and the graph depict the recharge factor, and as it can be seen, the rainfall factor varies from 7.9 to 15% from 2015 to 2012. Groundwater draft is the amount of water extracted from the borewell, and extraction of water in the existing borewell is depicted in the graph. Runoff. It is the water that flow over land as surface water. It is a critical factor in deciding the design of soil and water conservation and drainage line treatments, number of locations of water harvesting and recharge structures, water balance, water availability at the watershed scale. Two types of runoff is measured. One is soil phase within the watershed, and second, runoff at the watershed scale. Water balance and budget. Water balance is the quantity of water available from the rainfall after deducting various losses. And if you look at the table, out of the total 784 mm rainfall, only 71 mm is lost as runoff, and the same is depicted in the graph. Based on this data, conservation plan for watershed and proposed water harvesting structures are depicted in the map. In the end, considering all the parameters, Hydrology Atlas is prepared.